Hello, welcome. My name is Ulrich Kohn. I'm from ADVA. Today, I would like to talk about disaggregated networking for 5G. And I would also like to highlight the important role the Telecom Infra project plays in this domain. Let's start with a look at 5G. This is not just a faster 4G technology. 5G is providing quite interesting new features like improved resilience, so higher availability, lower latency, improved scalability, and this makes it a perfect technology for mobile network operators to extend their business into new market domains. Industrial services might benefit from 5G technology. One example might be a mobile network operator is providing connectivity to an enterprise on site for connecting sensors, connecting actors to industrial control processes. Those processes might run as a hosted application at the edge of the mobile network. All this will be possible, already is possible, with 5G technology. However, this requires some agility, flexibility of this 5G technology. There needs to be some integration effort of this interesting enterprise applications with the mobile network. So the mobile network will not be a closed down monolithic block which is not easily extendable with new features. It will be a very, very flexible agile technology. This is why 5G needs to be implemented in an open way as well as in a disaggregated way, which I'll explain in a second. But initially, let's look at the design practice applied today mostly with mobile networks. That's shown on this slide here. Today, mobile networks are mostly built with single vendor domains. One vendor domain, radio access network supplied by vendor A. Another region, the radio access network might be supplied by vendor B. But it's one vendor for one domain. That's a quite typical way how you implement the mobile network. Same thing holds for the core network of the mobile network. So quite monolithic blocks of technology for a major domain of the mobile network. And this somehow conflicts with what I just said. 5G networks need to be open, they need to be able to adapt to new requirements. Some integration might provide a mobile network operator with new opportunities to develop business. Not so easily achievable with closed down single vendor major domains of the network. And this is why we assume this design practice will disappear. That's shown on the photo on the right hand side. So this kind of approach will implode and will make place to a very different way how mobile networks will be implemented, shown on this slide here. In the center you see now an architecture of an open mobile network, highly disaggregated, horizontally disaggregated. Radio base stations are separated functional into radio units, distributed unit, and a central unit, connecting then to a highly disaggregated core network, but also vertically disaggregated, a user plane, control plane, management plane. And this much more fine granular blocks, technology blocks of the mobile network leave a lot of opportunities for specialized companies to bring in their solutions, their expertise by means of open interfaces between those finer granular blocks of the mobile networks. Someone needs to create the specifications. That's shown on the left-hand side. IMT, International Mobile Technology Specifications from ITU, as the basic framework which served us well for many, many years, has been the input to 3GPP, which specified 2G, 3G, 4G, and also the 5G technology. On the architectural level, the major building blocks and capabilities defined by this a standard body. And so far, we have then more on the interface side, the work done by ITU, by IEEE, by ONF. In between, there was a gap. There was a gap of better, well-defined, functional, finer granular blocks in the mobile networks, and this now has been filled out by the work of the Telecom Infra project or the ORAN Alliance. So they now make it possible that mobile networks can be designed, implemented, and operated based on finer granular blocks, open internal interfaces, blocks delivered with technology from various technology experts, and that's now shown on the right-hand side. It's not a single vendor, it's quite big ecosystems of expert companies who deliver these key components of the mobile networks of the future. However, this requires some sophisticated network integration effort. And again, Telecom Infra project, ORAN Alliance, they play a key role in bringing those ecosystem partners together. ORAN Alliance, for example, with their Blockfests or the field trials initiated by the TIP Infra project, played an instrumental role in integrating those disaggregated mobile networks. Some partners are shown there, technology partners from the silicon component side up to the network integration expertise SI companies. This is the way how networks will evolve from monolithic designs to open, flexible, agile, disaggregated open networks. TIP as the Telecom Infra project has been very early in defining disaggregated open architectures, like shown on this slide here, separating the radio base stations from the core and the radio base stations further into open disaggregated subcomponents, so isolating control plane from user plane, isolating the radio frequency part from the user plane part and the control part, and with a disaggregated unit and the centralized unit having this word horizontal disaggregation. But the TIP also focused very much on the connectivity network below, so the infrastructure which connects the radio base stations with the core function. This is where they started to define disaggregated routers, disaggregated cell-side routers, disaggregated optical transport solutions, as well as the control which is needed as the end control to bring together those disaggregated transport network elements. And this work has been extremely successful. Let me talk about the disaggregation of routers and the disaggregated cell-side gateway, key work of the Telecom Infra project. Why should a router be disaggregated? That's shown on this slide here. Historically, the router have been designed, developed by a single company, a company which did the silicon work. They developed operating systems for those devices. They developed the devices themselves. They put the application protocols on top in those components. And guess what? They might not be the expert company in all of those technology domains. So at the end, there is a kind of compromised solution. Disaggregation addresses this. Disaggregation allows that each of those different technology domains within a switch or a router are addressed by a specialized company. There's a specialized company for the silicon. There's a specialized company which is doing the component integration into a white box, a switch. There's companies which are experts with the software on top of that. Those are the companies with the operational experience, and there's companies with a lot of application protocol competence, routing protocols, signaling protocols. All those experts can bring together their key competence and create a solution which is much more superior in efficiency, performance, scalability, rather than a compromised monolithic single vendor solution. That's the idea, and this has very successfully practiced by Telecom Infra Project and the partners. Shown here is the timelines of the development of the disaggregated cell site gateway. The project team, ADVA was a founding member of that, started work in middle of 2018. With strong guidance and led by major mobile network operators, a specification has been developed until end of that year, and initially demos would not optimize components, but proving the feasibility of this approach have been shown at the Mobile World Congress at various booths just half a year later. This was followed by tendering of field trials. ADVA again was successful there, and under the hood of Telecom Infra Project, various field trials then have been performed and finally led to the rollout now of a fully disaggregated cell site gateway in live operation networks with mobile network operators. You might have seen the press release from Telefonica, which announced now the rollout of this solution in the US network in Brazil. Very successful. Benefit for the mobile network operators, benefit for the market is now choice. You can select the best component for your network, the best software. So ADVA is supplying software, network operating systems for white box switches, but there's also other companies who are doing the same. So choice for service providers, security, flexibility, agility is the value of that. And let me highlight one additional technology which frequently is overlooked and which drives disaggregation even one step further: synchronization. We all know that timing is very important for mobile network, especially for 5G. It's a very complex and difficult and sophisticated technology to deliver very precise time and information to the edge of the mobile network. Not all device manufacturers who are now integrating white box switches, white box servers, are experts in timing. While there is very specialized companies out there, like Oscilloquartz, a member of ADVA. So the idea is, why not adding synchronization as a component, as a disaggregated component to white boxes? And that's approach we are following here and shown on that slide here. This timing might be from an expert company delivered software stack. It might be using a simple standardized interface like an SFP port to plug in a sophisticated timing function, or an internal server interface like the M.2 interface might be used to plug in a timing function on a dedicated submodule. That's a very interesting approach, driving disaggregation further. Products are becoming available, software side as well as hardware. So this SFP-based synchronization solutions are already deployed in very high volume in the market. So short message: timing, keep challenge for mobile networks, there is now a disaggregated solution also for that. With this, I would like to come to the end of this short overview presentation. 5G, as I started, is not just a faster 4G technology. It is much more capabilities, but there's also a need to reconsider the design practice with 5G networks if you want to take most value from those emerging new features. And this ends in a more disaggregated network design approach, open networking, open standardized interfaces. As outlined, challenge is network integration. Here, TIP, O-RAN Alliance play a major role. We have shown how this works and how successfully and how fast new components can be developed and made commercially available. That's a path we will further continue. I showed with synchronization how it can be driven to a further, more fine, granular solution approach. That's the direction the industry are taking, and jointly with the Telecom Infra project, we'll continue to make 5G a success. Thank you for your interest.